Hello and welcome to another episode of TWiML Talk, the podcast where I interview interesting people doing interesting things in machine learning and artificial intelligence. I'm your host, Sam Charrington. I apologize in advance for a longer than usual intro, but we've got a bunch of news and announcements that we wanted to share this week. Thanks to everyone that listened to, shared, and commented on last week's show. Based on your feedback so far, it's pretty clear you're enjoying both the Industrial AI series as well as our more technical Nerd Alert shows. I am too, so you'll definitely see more of both. This week, though, we're starting a 2-week break from the Industrial AI series. I've got a great show for you today, and then next week, the week of July 3rd, we'll be foregoing our usual Friday release and experimenting with a shift to a Monday release schedule for at least the rest of the summer. When this podcast drops, I'll be in New York City for the O'Reilly AI conference, where I'll be interviewing speakers like Douglas Eck from Google Brain, Rana Al-Kaloubi from Effectiva, Ben Vigoda from Gamelon, and Naveen Rao of Intel Nirvana. Our O'Reilly AI series will be posted on Monday, July 10th for your binge listening pleasure. The following week, I'm in Germany, in Hamburg, Berlin, and possibly Munich. If you're in or near one of those cities and you'd like to connect, definitely give me a shout out. As we've mentioned over the past few weeks, we've been planning and now have finalized our very first TWiML Happy Hour. We've partnered with our friends from the NYAI Meetup Group, and we'd love for you to meet us at Ainsworth Midtown in New York City on Thursday, June 29th, starting at 6 p.m. right after the O'Reilly conference for a few hours of drinks, conversations, and networking. I'm looking forward to being back in my hometown and sharing a drink with those of you who can make it. Make sure to RSVP at twimlai.com/nymeetup to let us know you're coming. And now about today's show. Our guest this week is Zornitsa Kozareva, Manager of Machine Learning with Amazon Web Services Deep Learning, where she leads a group focused on natural language processing and dialogue systems for products like Alexa and Lex, the latter of which we discuss in the podcast. We spend most of our time talking through the architecture of modern natural language understanding systems, including the role of deep learning, and some of the various ways folks are working to overcome the challenges in the field, such as understanding human intent. If you're interested in this field, she mentions the AWS Chatbot Challenge, which you've still got a couple more weeks to participate in. Of course, a link will be in the show notes, which will be posted at twimlai.com/talk/30. I had a ton of fun chatting with Zornitsa and learned a bunch, and we couldn't wait to share this conversation with you. Enjoy. All right, everyone, I am on the line with Zornitsa Kozareva. Zornitsa is a manager with AWS Deep Learning, and we are going to be talking about deep learning and natural language understanding, and I'm super excited to have her on the line. How are you, Zornitsa?
Likewise. Thank you, Sam. It's a great pleasure to be here and to be part of the show. I'm doing really well.
Awesome. Well, why don't we get started by having you tell us a little bit about your background and how you got to where you are.
Yes. So currently, I'm a manager of the AWS Deep Learning Group at Amazon that focuses on natural language processing and dialogue systems. My background and PhDs are in the field of natural language processing, which focuses on building systems that understand what humans mean. For a couple of years, I wore an academic hat at the University of Southern California. I was an assistant professor there for the computer science department, and I focused on different types of research funded by DARPA and IARPA. And after that, I moved to industry, where I decided to tackle the same challenges, but at a much larger scale and with a bigger impact to humans and society.
Do you currently do research, or are you primarily focused on product-oriented work?
I'm focused on both. We do a lot of product development inside at Amazon, but at the same time, I'm making sure that I continue participating and serving the scientific community. We do have scientific work, as well as I regularly serve on the program committees, and I'm an area chair. So I'm trying to do both, but at work, definitely the focus is on building products.
Got it. You're currently working on the deep learning and natural language understanding systems that power Amazon Alexa and Amazon Lex. I'm pretty sure everyone knows what Amazon Alexa is. We've talked about it a bunch of times here on the show. And in fact, I demonstrated a few times how to access the show on Alexa. So folks are familiar with that, but I'm not sure everyone knows what Amazon Alexa is. So can you maybe give us a high level overview of that service? It was just announced last year at reInvent, right?
That is absolutely right. Well, let me walk you through how we ended up with Amazon Lex. So if you think about it, we live in the artificial intelligence era, and we see the development of very smart systems from self-driving cars to Internet of Things. But at the core sits this conversational assistant that enable the communications between machines and humans. And it has been a dream for developers and for sciences in general to be able to build such assistants. But if you take any developer and they have to build such kind of a system, it requires them to know a lot about natural language understanding and speech recognition, which are very tough. And you either should have a PhD or should have spent significant amount in these areas. Developer had to worry about how do I build systems that are really scalable? How do I enable testing and make sure that my bots are going to be working what the users need? How to do authentication? How to integrate the business logic? And all of these challenges were kind of blocking the development at a faster pace of all these applications. So we introduced Amazon Lex, which is a new service for building conversational interfaces for your apps using voice and text. And there are multiple benefits to that. One is Amazon Lex is very easy to use. It's built for developers. And we at Amazon do all the heavy lifting in terms of the infrastructure. We take care of the models. And the developer just has to focus on what is their customer use case and how they want these applications to look. The best part is we have very high quality text and speech language understanding, and they are powered by the same deep learning technology as Alexa. So that's why we have the short Lex. It's short for Alexa. The good part is also that any developer can seamlessly deploy and scale. If you build your application, for example, for specific platform, let's say Facebook Messenger, you can very easily port it to many other platforms and you don't have to worry about that. And at the same time, we have AWS Mobile Hub integration that allows you to do many things like synchronize data, analyze user behavior, track retention, integrate your bot, and so many things. So this new service, Amazon Lex, allows people to focus on what matters to them and literally solve a particular user need, whether it's booking a hotel or it's opening a bank account. And the most exciting part is we're organizing a challenge right now. It started in April and it will end in July. So those folks that are really passionate and want to build their bots, I encourage them to have a look at our webpage and just register for the challenge.
Oh, is that is it a prize for the best Amazon Lex app or something?
Yeah, there are different rewards. There's the monetary rewards, there's an AWS credits, and also folks can come to reInvent 2017. There will be ticket. And as I say, the focus is build a chatbot that engages users and at the same time fulfills a specific need that you have, like booking a hotel or any other thing that you might have in mind.
Okay, nice. So with that in mind, let's maybe talk about what are some of the biggest challenges in working on systems like this? What are you currently researching?
Well, my focus is in natural language processing, and the most hard part is to build systems that actually understand what the humans mean. This involves can we understand what intents people have in mind? Can we identify the slots that enable us to understand how these intents should be fulfilled? And for most people that haven't worked in this area, it sounds oh, that's pretty straightforward. But actually, language is very ambiguous and very, very hard to understand. If we deal with very explicit intents, let's say cancel travel to Miami, I just literally said every single thing that I'm planning to do. Cancel is my intent and Miami is my destination. But imagine I'm chatting with someone and they're asking me, are you coming to the birthday party? And I suddenly say, I'm on my way. If the conversational assistant pops in and says, hey, Zornitsa, should I send an Uber your way? That's amazing. So building such applications is really hard. It requires the system to understand implicit intents, which are very hard to detect. It requires the system to know what your user preferences are. Maybe I'm using specific means of transportation. The system has learned it over time, and it's making automatically the recommendation. And the ability to generate such kind of replies automatically instead of using templates that are already pre-specified. These are all very, very complex problems that are open-ended, and we are continuing to invest both in terms of sciences as well as in industry. How do you solve and make systems being able to handle all this complexity?
So maybe what's a specific area that you've been focusing on there in terms of your research?
My research focuses on building this natural language understanding capability. Anytime an utterances comes in, we focus on extracting those slots to fill in the template, as well as understanding what these intents are, such that when you pass that information to a dialogue manager or a component that communicates with the backends, we understand like what the human meant, and more correctly you extract such information, and the most accurately you populate it in these specific templates, then the better your system will be, and humans don't have to repeat the same question over and over again.
You mentioned a dialogue manager. Do these systems have standard components, independent of the implementation? Do kind of all of these systems have dialogue managers? And, what is the general architecture of these types of systems?
Yeah, that's an excellent question. While conversational assistant can live in different shapes and forms, like either on your phone or in your home device, even in your car, the common part is like they have very standard like processing blocks. Input is like either speech or text. And the first component that gets hit is the so-called natural language understanding component. That is the piece that focuses on understanding the intents and the slots of the users. Once that information is extracted, it gets passed to the dialogue manager. The task is to take these pieces of information, send them to the backend, and the backend, think about it. If you want to book, let's say, a flight, maybe I just say, book me a flight to Miami. Once you extracted the Miami term and you pass it to the dialogue manager, it communicates to the backend, let's say your favorite travel website, and it says, well, now I need to know what date you will be traveling. Do you have any price restrictions? Do you want it to be like a direct flight or not? It sends back all this information to the dialogue manager, says, hey, I need to have all this information filled. The dialogue manager passes the slots, and then they hit a natural language generation component that says back to the user, hey, can you tell me, do you want a direct flight and do you have any price constraints? That output could be both text or it could be speech. It gets sent back to the user, and then the user says, well, actually, I don't have any constraints. Find me, let's say, the cheapest flight. So this constant loop between these three components, natural language understanding, dialogue manager, natural language generation, is what drives the whole conversation between a system and a human. How you implement them, it depends on you as a developer, how you decide what models to include. But on the high level, these are kind of like the three building blocks that everyone has to focus on building.
Okay, and then even within the NLU component there, we can even break that down further. I know, or I recall that Google a while ago, I guess around a year ago, announced like an open source parser, their Parsey McParseface tool, and that's just one of the different pieces of the NLU component itself. Like, what does that part look like?
Well, think about it that the natural language understanding components there, as I said, they're different and depends what your need is. Okay. And the tools that you quoted, they're kind of like a high-level dependency parsers or just a parser. You can use that information to facilitate how to build this kind of natural language understanding components. But at the core is like you have to think about how to define your slots, or how do you define your semantics? How do you define the space over which your system will operate and would semantically understand what a human means? And these things typically are called slots. They're the entities and semantic bits of information that capture what our request is. And you can build them from scratch. You just need to know like what are the right machine learning models for that. Or if you want, as I say in Amazon Lex, we have like pre-built capabilities such that people can just choose from a drop-down menu. So that enables like a person who knows nothing about machine learning to be able to build them. For anyone that is from natural language processing field and has dealt and worked in semantics and information extraction, it is much easier for people with such kind of skill set to be able to build their component from scratch and to know how to define these semantics or how to define the space that the machine learning system should operate over and make predictions.
And how do you characterize that space? You're starting with typically, some audio waveform. Like, what's the process for getting that into, some parsed set of slots that you can then operate on further back in the system?
Yeah. So once you have the speech, as I said, the input could be both speech that you transfer from speech to text, or it could be the text itself. Think about it like a text messaging. Once you have that text in, what you do is like you have to make the design of what the intents and the slots are. And oftentimes people come and ask me, well, where do these intents and slots come from? And the answer is they're the designer's choice. You can take them from an existing large ontology, just pick the pieces that you care about. Let's say in travel, you might care about cities and countries and so on. You can automatically learn them from a lot of unlabeled text, or you can even manually create them. So how do these slots look like? Let's say we're building a shopping bot. Then we can decide that our slots are the things that are most important: products and vendors and brands and models and product families. And the intents, or which are the actions on top of which we can do operations, are buying them, selling them, recommending them, tracking them. What we do is like we formulate this type of problems as a sequence prediction. Like if I give you these categories, the products, vendors, brands, and I give you some text of length M, like can you find segments inside the text that can be labeled with these specific categories? And the moment you do that, then you're having this rich representation that you're caring about and that your dialogue system can ingest and actually build on top of. So you have to annotate your data in the correct way, meaning if I say purchase Adidas shoes, Quick 2, and Nike Pegasus, each word, or how to say segments of words, they get tagged with this specific information, and then the machines just ingest it such that they can build prediction models on top of that. And that's one way you can do it. Yeah.
Okay. And so one thing I'm inferring from your description is that you consider, or it's generally considered, that the speech recognition component of a broader system like Lex and the NLU component of a broader system like system are like two different things. Is that the way you tend to think of it? Like this, you're getting speech that's already turned from audio signals to some set of symbols, whether that's language or something else, and then that's what you're working to understand. Is that right?
That is correct. Yes. Think of them like different building blocks that you need to piece together in the right way such that you can build a complex system that is going to be able to drive this dialogue. So in my case, I just focus on the natural language processing component. And we have amazing colleagues that do the same thing. They focus on speech, or they focus on generating from speech to text. Yes.
So when you were talking about the intents and the slots and looking at that problem as predicting a sequence, that makes me think of deep learning models like LSTMs. Do those come into play there? Talk about the impact of deep learning on all this.
Yes, absolutely. You have very good intuition, and LSTMs are very useful in solving such type of problem. It's a structure prediction problem. And as I say, until recently, people used to employ a lot of the traditional supervised learning, once they pick their favorite algorithm, being a CRF tagger or being like learning to search algorithm, most of the focus was on how to do feature engineering and find what are the right features and how do we iterate over those features. But now with the big wave of deep learning, we see that one can build such kind of systems. If you're an expert in the field, one can build them much faster in terms of like picking the right algorithm. You can train your word embeddings on a much larger unlabeled data and also get much more powerful results. So LSTM is great for solving this kind of structure prediction problem. And typically we see very good results if you have the last layer with conditional random fields.
Can you elaborate on that? What are conditional random fields?
Yes, it's very, very standard. They're like discriminative classifiers. It's very, very standard, built for many decades and used in this kind of task. They're used, as I say, for sequence prediction, can encode relationships between the observed data. Like typically the current and the previous word does not model long-range dependencies. While in the LSTM, you have these deep learning models, which are more powerful. As I said, they can learn powerful representation given enough data. They can capture the long-term dependencies, not only in a sentence, but even they can span between sentences and paragraphs. And as I said, the best part is like you don't have to focus on feature engineering. You can just pass the raw data as input.
So if you're looking to build a system like this, what are the primary considerations that you need to think about to architect it correctly and to build a system that meets, a specific set of needs?
I would say if you are familiar with machine learning, if you use these sets of methods or methods that are appropriate for structure prediction, your problem will be kind of solved. But the part that one really needs to focus on is the data, because the data is going to drive the quality of how your system performs and behaves, and the semantic representation. This means is like how are these labeled spaces going to look like. In terms of like the machine learning algorithm themselves, there's like plenty of open source platforms that people can use. At Amazon, we have the MXNet platform, which is an open source machine learning platform. We have TensorFlow. People have a wide variety of choosing which machine learning toolbox they can use. And as I say, that's pretty easy to pick up. But the hardest part is like, if you don't know how to get your data, if you don't know how to represent it right, then even if you have the best toolbox on earth, you won't be able to build your applications in the right way. So I encourage people to look at both things, not only at the machine learning side, but also on the side of like, how do I design my system? How do I collect the data? How do I drive all of these processes together?
And you said making sure you represent your data right is one of the big challenges. What exactly does that mean, and what are the considerations there?
Yes, well, as I said, the biggest problem is like semantic understanding of like what humans mean and how should the computer encode and understand that. And that's a challenge. And it's been a challenge for many years. There are theories, but yet building such a system that understands us humans is very challenging. So we have these basic representations that can to some extent work, but that doesn't mean that really understand what a human means. It's very hard for the systems to pick up like sarcasm. How do you take it, represent it, and even like model it? These are much harder things we have to account for. Right now we have these basic, more flatter or slightly more structured representations, but that's definitely not the way to go forward.
I'm trying to put that into context. If I'm thinking through, building out a system to understand language, and you're advising me to start with the data collection and representation, I get collection. Obviously, it's going to be, or depending on the situation, it may be difficult to collect the data, but assume that I can collect a bunch of data. Say, let's assume it's in text form from, bot requests or something like that. The next step you're saying is the representation. Where does representation come in before I start throwing my data at the machine learning algorithms? And put another way, like part of what I'm expecting or hoping the machine learning algorithms to do is to kind of parse the data and, help me figure out how to represent it. Is that right? Or
well, there are different ways one can do it. I'm also hearing a good thought from your side, which is like, can you even build the machines, or can you build a machine learning algorithm that can, given just some chatbot, can automatically infer what the slots should be, what the intent should be, and definitely that's possible. It's not going to be very accurate because it's almost like when you do clustering over documents, right? You can end up with these different representations, and the same thing is going to happen here. So that's why typically you start with the notions of you defining your slots and intents. So when you build the machine learning applications, typically you have the classes, right, that you want to output. Meaning, if I give you a large document collection and I say, well, I just want to know, is this law, is this medicine, and so on, you already have these categories. So it's the same thing for building these natural language understanding components. You need to know what categories or what is your space over which you're going to operate. If you try to learn that automatically, as I say, you're going to end up with these coarse-grained, very high level, you define like meanings, and they won't be sufficient for you to build a meaningful application.
Right.
But if you sit down and actually write it yourself, you have much higher chance, because think about it, just to build a flight booking system. If you open the different travel websites and you see like what are the minimum sets of inputs they require you from the destination to destination, time, location, and so on, and you just define literally that to be your space or the slots over which the system would operate, you're going to be able to build much better system. And to be honest, yes, one of the pushes in science, both and in terms of industries, like, can you build systems or conversational assistants that can learn from human interactions and that you can teach? Right now, if you ask something to a system, it will tell you, I'm sorry, I'm not quite sure about that, or like, I'm still learning. In reality, it would be really awesome if you make those systems learn, such that anything you say, and based on how people have replied, plus like requests for new, let's say, for new information that you haven't seen before, if the system can learn it and starts asking about it, or sees many people are talking about it, then this is the place where we want to go, because humans cannot encode all the knowledge in the world. And where I'm headed at is like, if you look at how all of these applications are built, they are operated over different domains, which means you have a movie domain, you have like a music domain, shopping domain, and so on. And each of these domains have their semantic representations, or so-called slots and templates that you can call and you can fill in. But a human cannot sit down and represent the whole world in these frames, right? It's too time consuming, it's labor intensive, it doesn't scale. And most importantly is like, we humans don't operate per domains, right? I can say, order my pizza and book a flight, right? I just cross two different domains and I express multiple intents. And that's the main reasons why it's, how to say, it's like the current technology is great and it solves real use cases, but there's like many more things that have to be done, and we have to focus on figuring out, well, how do you build end-to-end system that can operate for any domain, that can operate for different languages, and that can continue to help assisting us.
And so what's the state of the art there? Are people building, a bunch of individual domain knowledge and then using some deep neural network to kind of identify which domain is being asked about in a particular utterance? Or are they building, kind of bigger, flatter models? Is there any particular direction now?
I think, yes, one of the most common trends that I have been seeing over time in this field is for people to try to focus on the different domains, and for each domain focus on the slots. And sometimes I've seen people trying to transfer knowledge from similar domains. Let's say I know everything about reserving restaurants and I have a little bit of data for hotels. Now, can I learn how to reserve hotels by knowing how to reserve restaurants? So that's the most common approach. And as I said, it's a challenge because it doesn't scale. It just doesn't work. The ideal scenario is like, can you build a system that doesn't have these boundaries and can just like operate over anything that we have in mind? Yes, in terms of like what algorithms, yes, a lot of people do use deep learning, as I said, different parts of the components. Yeah.
Yeah, and I guess deep learning isn't really fundamental to my question as much as is the best practice or is the research frontier. If I'm trying to build a system that can handle hotel reservations and pizza orders and buying cars and, multiple things, am I likely to be better off getting a bunch of data for each of those, building out specialized representations for each of those and training models that perform well for each, and then use some kind of discriminator that can figure out which model to use? Or is there some other kind of technique that at that meta level, to pull it all together?
Yeah, if you're building a production system that has to work and satisfy user and customer needs, then that's the right way to go. It will guarantee you, one, that your system is going to be doing the right things, and it will have higher precision, which is what's very important for users. Nobody likes to hear the same question twice, like, what did you mean? I didn't get your request. In terms of research, I think people can have much more flexibility, and they can use all kinds of techniques. They can use like transfer learning to see like, how do I transfer my bot that I built, let's say for restaurants, into flights or into something else. Mm-hmm. And I think these kind of transfers are more successful for things that are closer to each other. There are some papers that I have just seen on general like entity recognition and sentiment analysis, but the thing is like they've been evaluated on much smaller data. So ideally what I really would like to see is like people doing it on a larger scale with lots of data and having many of these domains and actually showing like how possible it is and where are going to be like the biggest like challenges. Also, you can build the system in a different way. Like if you want, you can build these individual components and then you have something on the top that actually ranks your results and tells you what's the most likely domain, sets of intents and also slots. Mm-hmm. Or you can build one big giant neural network architecture that you can incorporate. Let's say if you have your LSTM, you can make it learn both your slots. It can learn your intent as well as the domain. And over time, with a lot of data, you can learn these constraints that in certain domain, let's say like movies, it's very less likely that I do an action that is, let's say, possible for a different. I would say that if you are building a real application, then stick to what works. If you are passionate about exploring and pushing the frontiers and doing like a lot of research, then definitely there are many more like open doors in terms of like trying to see like where is the boundaries and how far can we get.
Great. Let's talk about the data a little bit. Are there standard data sets that folks are using for these kinds of problems like there are in the image recognition side of things?
I've seen like there is some challenges that are called the dialogue state tracking challenge. They do focus a lot on the dialogue manager component, and there are also these attempts with these different same data challenge that people can do the knowledge transfer that I was talking about. I've seen people use different types like Ubuntu chats, and that's like if you just want to build like a high level chatbot system that it's not goal oriented. And then I've seen a lot of work from Facebook AI that drives in that area, and they have a data set that's called Babi. It's very
called
interesting.
What?
I think Babi.
Okay.
I'm not sure how the right pronunciation is, BABI.
Okay.
But it has like different tasks, like 20 tasks, and it's annotated and people do use it for conducting research. So this, if somebody wants to like start in that area and wants to play around, maybe these are good places. As I say, depends, like do you just want to build like chatbot that doesn't have any goal for human, or do you want to focus on building a real working system that is going to fulfill your goals for you as a human?
And now if you're building a system like this and none of these data sets work for you, you've got to figure out some place to find that data. And I noted that you've got some research experience into large scale knowledge extraction from the web.
Yeah.
Are there any techniques there that you might use to help you collect a data set?
Well, you can do different things. People have invested a lot of effort in building this Wizard of Oz systems. It means like you can build very quick application that simulates a scenario. Let's say one person will pretend he is the booking expert and the other one will be the customer, and they can drive the conversation on their own, and the booking agent will just try to fulfill that intent. So if you create such scenarios and record all the data with different people's interacting, that could be one easy, quick way to start building your application. Another way could be that
and,
you
and
can
just
even
to drill into that, what you're suggesting there is that you define out these scenarios, and then are you thinking like go to someplace like a Mechanical Turk and say, hey, you play the booking agent and you play the customer, and you get kind of random people to explore these scenarios? Or do you mean something else by that?
Yeah, it's perfectly feasible. Yes, you can exactly do that. Like kind of decide what the application you want to build. You can set up everything being on Amazon Turk, or being even, let's say you're a startup and you don't want this information to be leaking, then you can set it up, even build your own very quick in-house application that just can record these conversations.
Mm-hmm.
And once you have that data, then you can start building, let's say, a first prototype. You can even launch it and then test it on real users. When the data comes back, you can start iterating. And once you have this kind of nice loop, you can keep iterating and improving what you have done. That's one way. Second way is like completely even focus on, let's say, like just Amazon Mechanical Turk. You can either have predefined questions, but then the conversation will become very artificial, or you can play the game that you have just explained. And then on your questions, like, can we do something if I give you the whole web? What can I do to facilitate the building of such system? Like at the core of these systems is like a knowledge component. You have to have knowledge bases that help you extract this information much more accurately, that help you get world knowledge. And one way is that you can get that world knowledge if you don't have your own knowledge graph. You can get that world knowledge by literally extracting all of that information from tons of web pages on different topics. And you can integrate it inside your models, right? Either as additional features or additional signal, and help drive these applications to be more precise and more accurate.
Interesting. You did a talk on dialogue systems. Actually, that's coming up, it looks like. Is that in the same kind of domain of the things that we've been talking about thus far, or are there different aspects to that?
Yes, that was like kind of the core component of like, if people know machine learning and they want to build everything from scratch themselves, is like what components should they focus on, what machine learning algorithm they should work, like pick up, and then how to get the data. And at the same time, it's like, what's the expectation? Some people have the expectations that this system should be like 99% accurate. And I was like, oh, not really. We're doing these baby steps in the field. For some very specific basic things, you have high accuracy, but that doesn't mean that you have solved the problem. It just shows that the solution of such task is possible, but doesn't mean that it's a solved problem.
So you bring up accuracy, and that raises some interesting questions, I think. On the speech recognition side, there are some standardized measures of accuracy, and you have folks like, Microsoft and others reporting their accuracy. And in fact, Microsoft recently reported, or I think a number of organizations have recently reported human parity in recognition. It seems like it's maybe not quite as straightforward to report accuracy on the NLU side of things. Is that true or no?
Well, actually, no. Think about it, like when we annotate the data, you typically have your training set, your development set, and you have your test set. And for each of those, we always measure what is your precision, what is your recall, what's your F-score. We go on the level of each of these slots. And we also record other things like how hard is the task for a human. We measure the kappa agreement, the Krippendorf alpha. And the idea is that if you see how hard the task is for a human, then expect your system to be 10% less than that, right? So if two humans have really hard time annotating your data with your representations, this means that it will be extremely hard also for that system to learn about it. My point was that building the natural language understanding systems is much harder than building a, let's say, image understanding system. And the challenge is like language is very ambiguous. We have to deal with a lot of slang that people might be using,
Right,
or
right.
specific like metaphors that people have in mind. And so the building of a system that can understand and operate on top of that, right, is very hard. That's why I was saying that it's important to have your knowledge bases hooked up such that the system can get, think about like a cheat sheet, like some extra information that can help it facilitate, understand better like what we mean.
Right. Yeah, I think that's what I was getting at with the accuracy question. I can think of many occasions, often happening right here at home, where I definitely understand the words, but I'm not sure I totally understand the meaning. And while I can certainly grade my system's accuracy relative to, some label set, it's harder to capture even the right metrics in terms of, you mentioned this earlier in the conversation, like, do we even have representation for,
Yes.
nuance and sarcasm and, things like that, if I had some uber metric of, hey, does the system understand what was being said, it just seems way more difficult to really capture what that even means.
Yes. And, like back in the day when I was like with my academic hat, I had a grant from IARPA that focused on, can you build systems that understand metaphors for 4 different languages? It was Arabic, Russian, Spanish, and English.
That
and what that
understand
means,
what?
Metaphors.
Metaphors. Got it.
Yes. And you had these 4 different languages like Spanish and Russian and Arabic and English. And the idea was like, we just pass any text could be used. Can you find those metaphors? Can you interpret them? And also assign the sentiment that the person had when he said that metaphor, right?
Mm-hmm.
So if I say my lawyer is a shark, so we know that, sharks are vicious, but it's really good for me to have a lawyer like that, because it means that the lawyer is going to do the right thing and they're going to protect you.
Yeah.
But if I'm saying this to you, then for you, that is going to have a negative connotation, right? So it was really hard to build systems that just given any free text in these languages, it can identify the metaphoric expression, interpret what they mean. And we focused like 2 years on just building and trying to solve it. And unlike other tasks in natural language processing that have matured over time and that have like significantly higher performance, building such kind of system that understand metaphors was very hard. It's like in the 50%. It's really challenging.
Yeah, again, going back to my previous point, it's even hard to, before we get to building the system, to think about what performance even means in this context, right? I think even that statement about my lawyer is a shark can be, can probably have either positive or negative sentiment depending on the circumstance.
That is correct, exactly. But the best part is, like, as I say, language is very hard, and there are a lot of people trying to solve these challenging tasks. For some of them, we've made tremendous progress. Others are open-ended, and we're still working on them. And that's what excites me, because it means that we have a lot of work to do, a lot of efforts to put into building such systems.
Absolutely. Absolutely. What are some of the other areas that you're tracking that you're seeing exciting work happening in?
In natural language processing, there is like a lot of focus on question answering and building both type of systems. Like if I give you a knowledge base, can you do question answering over this knowledge base and do inferences on top of that? And we have seen open-ended question answering where you have a document and just somebody comes in and types a question like this on the spur of the moment. Then can we find the corresponding answer in that document? Mm-hmm. They're both very challenging and exciting. So this year I was area chair for ASIA, which is Association of Computational Linguistics conference, our top tier 1 conference and like the biggest natural language processing conferences. And the areas that were trending a lot were information extraction and question answering. And there's like a lot of effort, some challenges that are coming up, and people have just been given the data and given the ability to think about how to innovate and how to solve them.
I know Quora is among the folks that have data sets for question answering, and there's another popular one, at least another popular one that I'm forgetting the name of right now.
Yes, that's absolutely correct. Like Quora has a nice data set. You have Squat, who is coming as a data set developed by University of Stanford, Percy Liang's group. And that's it's a very good data set. It has a lot of training data, magnitudes larger than previous data set. And it has different types of categories of questions. So that kind of mostly simulates or approximates real case scenario. And that data set focuses on the second question answering type that I was talking about. You have like documents and then you have a question like, can you find the answer in the document? And it's much challenging because people can ask the question in any form using different paraphrases, and then finding these spans with the correct answer is way harder than traversing a real knowledge base.
And so are the core techniques that are used for these two different types of question answering tasks the same, or are they dramatically different?
Well, I've seen people that use, let's say, knowledge graphs to answer questions, to use more graph-based algorithms. And I'm seeing a lot of trends with deep learning for the second kind of problem with this squad data set, which is more like machine comprehension from text. And people have different architectures of how they solve it, but let's say for the machine comprehension one, I've seen very common is like people try to represent the question into some kind of an embedding or vector space, and then they have the document. They try to use like attention mechanism on top to pick up entities or pick up spans that could be a good match for the answer, and then they kind of try to have some similarity between the question and the answer. So yes, both of those different types of question answering have wide variety of methods that have been employed, but these are two things that I'm noticing are kind of trending when people publish their work.
So for the knowledge graphs, I'm imagining there that you're using some kind of technique to identify, well, maybe a precursor to that is, what types of representations are you using typically on your documents that you're trying to do this question answering for? Are you, doing things like trying to do semantics and like identify, nouns and verbs and that kind of structure, or are you operating on a lower level than that?
Oh, well, actually, yeah, that's what I was saying, that this data set, I like it because one, the magnitude is much larger than any previous data set, and two, you have to focus on extracting different types of bits and pieces. And sometimes they could be just a word, a phrase. They could be combinations of like just like a noun phrase or much harder. It's not like a single answer, like when was Barack Obama born, and you just say the year, right? That's what a knowledge, like a question answer over a knowledge base does. This one is more open in that if I say like, hey, what were the symptoms for people who have cardiac arrest? Maybe the answers were contained in different paragraphs, and you have to find those different paragraphs and the exact spans with the answer. And that's what makes it much more challenging, but at the same time, much more useful, because most of the information that we need and the questions that we have, they lay in these unlabeled documents that are being on the web or that you as a corporation might have, and you might want to just search for the information. So I personally prefer this type of question answering work because it's, as I say, more real case scenario, and second, it's like more useful to us.
And so just to take a step back, so with these question answering data sets, in particular the Stanford one, the data set includes the base document and then a set of questions and answers from that document. And are there multiple answers for each question? And to what degree do the questions overlap?
Yes, that's a great question. So typically you have something like one question, like I'm just reading from the official paper that was published, which governing bodies have veto power. And then you have a whole document that, let's say, is talking about something, right? There is one specific sentence that can have this answer. For example, the European Parliament and the Council of the European Union have powers of amendment and veto and so on. So given that question, then the idea and this document idea is like, can you find the paragraph and more specifically the sentence that contains this specific type of an answer? And I haven't like dug deeper in terms of like understanding like how many of the question, the exact, let's say, question could be found with the exact answer inside. But I do know that the creators made sure that when that data was annotated, that they asked people, is like, if you read this article, can you ask a question using paraphrases, which means like different words or different ways that you can ask about it. So it doesn't have to be the exact same, exact same phrasing. If you had the exact same phrasing, then the problem is much more simpler, right?
Mm-hmm.
But definitely that's much more challenging data set, the way it was created and the way it's annotated. So I think they did a good job on making sure it's created the right way. It has different complexity. Yeah.
So that helps clarify it for me. Like what you're fundamentally trying to do is you're given a question and you're trying to essentially index into this document the particular sentence that answers it, which is a totally different problem than, or at least it is a more narrow problem than, synthesizing an answer based on, multiple sentences in the document, or a summary type of problem, or,
Yes.
trying to pull pieces from, two different sentences that are required to formulate an answer.
Yes, that's more like a summarization, what you are describing.
Mm-hmm.
And there, the goal is a little bit different. If I give you one or multiple news articles about the same topic, is like, can you find sentences such that you can summarize the text in a much more compact fashion? And for a human, the moment they read it, they get the gist of the facts, and at the same time, the whole summary is coherent and has natural read and flow. There are data set that has been created on that area. It's just the problem is called more like summarization, right?
Right, but there's some overlap, right? So if just to construct a simple example, if I've got a document that says somewhere in it, my favorite color is red, and then the next sentence is, but I also like blue and yellow.
Correct.
Right? And if you ask a question, what colors do I like? There's got to be some synthesis or summarization in there somewhere. And, is that, typically part of the question answering? Is there a set of work in question answering that's looking at those kind of more complex scenarios, or are there folks that are trying to combine the question answering and summarization pieces to, answer these more complex questions?
Yeah, if I'm not mistaken, there are people who are trying to do both. I've seen, mostly like focusing on one, but not at the two. But I'm sure that there are people who work on that. I'm just not aware at the moment of, or I don't have them on top of my head for such papers. But like there's a researcher called Sasha Rush. Like he has a paper on like how do you do this summarization that you were describing with attention mechanisms. So I'm sure that very likely there could be a work combining both of the things that you're describing.
Mm-hmm. So if someone wants to dig into this more, do you have any go-to resources for getting started?
Yes. For example, depends on what your aim is. If your aim is to stay on top of the natural language processing field, a great place is just to go to the ACO ontology and all the different NLP conferences. They're indexed there. You can see the latest papers organized by years and by tracks. So you can pick your favorite track, being question answering, being parsing, being machine translation, whatever excites you. And it's great to just sit down and like read through these papers and such that you can get on a higher level what is it that people are working on and how far they have advanced. If somebody is just a beginner and they're trying to learn about the field, I encourage you can look at Stanford's class on deep learning, like natural language processing with deep learning. It's taught by Chris Manning and Richard Zohar. Both of them are like leaders in the field. And it's a good place to start and just kind of learn both about like what are the problems in NLP, like the basic ones, and then how do you solve them using deep learning. And there are a lot of books people can just take and read specific chapters. So it really depends on like what is your end goal. Is it learning or is it like just download and build? There's plenty of open source code that people can use as well just to run something basic and understand what's happening.
Mm-hmm. And to bring us full circle, if all you want to do is, build systems that use this stuff, you can use services like the stuff you're working on at Amazon.
Yes, you can do that. And as I say, it's like one is if you know nothing about machine learning, but yet you want to build such systems, you can use a lot of the pre-built things, and we've done the heavy lifting for you. If you are passionate about machine learning, you know the algorithms, and you love implementing from scratch, you can use like open source like MXNet, which we are supporting. You can use TensorFlow. You can use any of those tools. It's just depending on like what's your level, and also like, are you on a deadline, or are you in this like learning exploration mode?
Mm-hmm. Mm-hmm. And do you foresee a future that allows folks to combine elements of both? And in particular, what I'm getting at is, now your choices seem to be, I can use a service like Lex that's, pre-trained, or I can, roll my own and, train using my own data. And, the presumption being I'm trying to get more accuracy by, training on a more limited, the more limited corpus that I'm concerned about. Do you see over time the kind of AI as a service offerings allowing you to upload your own data and train on it and somehow augment, their pre-trained models?
Yeah, I think that's exactly where like future is headed. Definitely people have their own data sets, their own requirements. If they have the data scientists also like available, doing exactly what you described is possible. And I think that's a fantastic way to take advantage of your in-house data, take advantage of your engineers and put them on a mission, or put them on a task in which is like, okay, improve these services, augment them, make them better. So definitely, I think that's a great place to be, and in a great area to invest and focus on.
Great. Well, I really appreciated all the time you spent with us today, and I really enjoyed the conversation. Thanks so much, Zornitsa.
Likewise. Thank you very much, Sam.
Bye.
Bye-bye.
All right, everyone, that's our show for today. Thanks so much for listening and for your continued support, comments, and feedback. This is your last reminder. If you are in New York today, June 29th, Thursday, join me this evening at the happy hour I'm hosting with the NYAI Meetup. If you'd like more details, please sign up using the form at twimlai.com/NYMeetup. The notes for this episode can be found at twimlai.com/talk/30. For more information on industrial AI, my report on the topic, or the Industrial AI podcast series, visit twimlai.com/industrialai. As always, remember to post your favorite quote or takeaway from this episode, and we'll send you a laptop sticker. You can post them as comments to the show notes page, via Twitter mentioning @twimlai, or via our Facebook page. Thanks so much for listening, and catch you next time.